This is TWIS. This Week in Science, episode number 814, recorded on Wednesday, March 3rd, 2021. How wild is life? Hey everyone, I'm Dr. Kiki, and tonight on the show, we will fill your heads with trappings, fat, and lies. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Trust the science, but more importantly, learn about science. Recently, a recent addition to the United States Congress put up a sign outside her Capitol office that read, "There are two genders, male and female. Trust the science." That is the same individual as also professed belief in a solar-powered Jewish space laser that caused the California wildfires, that 9/11, global warming, wearing masks, and voting results are all hoaxes, that victims of mass shootings, many of them children, were paid actors. Just goes to show how fringe a fantasy two genders is. So let's take a look at the science on gender for a moment. Genetics, we have learned, are not gender. Science has confirmed that gender occurs across a spectrum, that having a specific gender along that spectrum itself does not always imply or correlate to a set physical, emotional attraction or to sexual behavior. University of Liège, Belgium found that transgender brains resemble their late identified gender even at an early age, suggesting that gender is structurally different in the brain, not just the genitals, and in fact, it does not originate in the genitals at all. The check mark next to sex on a birth certificate is just a guess of what took place in natal development, where all sorts of factors contribute to gender. And when a child is born with both, choosing a gender for the child with surgery has led to tragic consequences. The DSM-5, published by the American Psychiatric Association, contains the condition gender dysphoria, which has been used to distinguish people who are experiencing socially driven emotional stress over gender identity from people who are experiencing bipolar disorder, which previous DSMs might have wrongly categorized them as. This congressional person claimed that science backs up their opposition to a bill affirming equal rights for non-binary gendered Americans, without having even the foggiest idea of what science actually has to say. And went on to say that gay rights in general has everything to do with attacking God and believers. Whomever believes that human equality is an attack against their God needs a better God. Or better yet, you can just leave God completely out of it and put your trust in This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. What a disclaimer today, Justin. You brought it. Faux show.
Do not take the name of science in vain, or you shall be smitten.
Smitten.
We'll smite on you. We will smite on you.
We will smite.
Smite. Is that
Smite thou with thine tongue lashings? No,
Smite
anyway.
with thy blade of data.
Data, yes. Welcome, everyone. We've got a great show full of science for you today. It is World Wildlife Day, so just remember, it's a wild, wild world out there. And what a wild world it is. Everything relates back to wildlife, so hopefully we will be touching on that throughout the show. But I have stories about, well, not necessarily wildlife, but space hurricanes. Because, yep, apparently that's a thing. Yeah, now it is. We will talk about those. I've got some lying lyrebirds and some...
Lyrebird's gonna lie, I suppose.
Lyrebird's gonna lie. That's right. And we'll, at the end of the show, get into some Neanderthal news. We will. Yeah. Justin, what'd you bring?
I've got how to match the fat to the wine instead of the wine to the food. A update on a dinosaur that's not a dinosaur. The absolute worst idea I have ever heard and how to handle climate change. The absolute worst idea.
Wow.
Yet. And good news for people who can't see color or very much else.
Oh.
Did you bring that story specifically for Blair? Just a little.
Yeah, I won't tell anybody. It'll be no. Actually, I think it does apply. You're right. To Blair. I didn't even think of it.
Blair, what is in the animal corner?
Well, if you try hard enough, anything applies to me. But in the animal corner, I have
wildlife.
I have lots of wildlife. So I have a story about wildlife that play dead. I have a story about wildlife that are very smart. And I have a story about wildlife that are dying from climate change.
Okay. I don't like the last one, but
it's
okay.
more of it's meta. It's very meta. So it's not, you don't have to picture anything. It's just
picture
like
a world without any wildlife.
It's like a computer simulation I'm reporting on. It's all right. There were no actual animals harmed yet. In this study.
Good. Okay. All right, then. Let us start to dive into the show. But first, I need to tell you that you need to mark your calendars for 4 p.m. April 17th, 4 p.m. Pacific time, April 17th. That's a Saturday. It's going to be the crossoveriest crossover show in history. The Daily Tech News Show and the TWIS crew are going to be joining forces, bringing the powers of science and technology into alignment for one great super sci-tech show. Let us know what you want us to talk about on that show, because we have lots of ideas, but we really want it to be very viewer forward. We want to respond to you and give you the kind of conversation that you are hoping to get out of such a crossover show.
How are we going to do that?
Well, they can email me, Kirsten at thisweekinscience.com. Okay. Yeah, makes it very easy. But remember, mark your calendar, April 17th, 2021. It's just like 6 weeks away or so. It's very soon. It's going to be so much fun. 4 p.m. Pacific time. And if you are not yet subscribed to This Week in Science, you can find us all places podcasts are found. Look for This Week in Science. You can also search for This Week in Science on YouTube, Facebook, and Twitch, where you will be able to find us, subscribe to us, and get the show every single week. Our website also is twis.org for more information. Now for the science. Okay, World Wildlife Day needs trappings. Lots of wildlife trappings. And I don't mean wildlife in traps.
Good.
I mean camera traps. Camera traps. It's really great. Researchers have just completed and reported on one of the largest camera trap efforts in history ever. It's massive. A massive effort is just published in the Proceedings of the Royal Society B. That's the Royal Society's flagship biological research journal. These researchers were around the world, part of a team. It's called Tropical Ecology Assessment and Monitoring Network. The team network uses motion-activated cameras to monitor species and their trends in tropical forests in Asia, Africa, and South America. So this is tropical ecology. They're trying to see who lives in different places. Now, their paper is based on the idea that we have species ranges. It's kind of like, we've been studying this species and we've seen it in a few of these places, but based on its ecology, we expect it to be able to live in all these places, not actually knowing for sure whether or not it actually does live in those places. So these researchers set out camera traps, and this is data from 15 wildlife preserves around the world, and has really set out a relationship between biological diversity, the productivity of the tropical rainforest that the wildlife preserves are in, and also human activity. And the relationship is if you have a very productive ecosystem, a primary productive ecosystem means that plants are producing a lot of planty goodness. And that gives insects and herbivores things to eat. And then the herbivores become meat that carnivores can eat. And so you suddenly begin to develop a big food web because you have more support. The more primary productivity you have, the more support you have generally for greater biodiversity. And what they have found in their analysis is really what they say is more unique animal traits. So the more productivity there is, the greater likelihood that you're going to find an animal that you don't find anywhere else because it was able to really specialize in some niche because it has the whole ecosystem can support it. So less productive ecosystems, generally less biodiverse via this relationship. They also discovered, and surprise, surprise, that when humans get involved with forest degradation, deforestation, encroachment, and hunting and agriculture and all the things that we do, biodiversity tends to go down. You lose those unique species regardless of the actual primary productivity of the ecosystem. So the ecosystem might still be able, or the ecosystem that's left might still be able to support biodiversity, but because of human activity, those unique species, and they're very often more top of the food web, the top predators or other animals or larger animals, they disappear in the ecosystems. So moving forward, it's there's going to be more of this camera trap analysis of wildlife and ecosystems. And it's so wonderful that they were able to document really where species are, who the species are that are in different places, and really start to get an idea of ecosystem health and potentially how we can start to develop programs in line with human activities to reduce our impacts on those ecosystems.
I love camera traps because they create just massive sets of data that everyday people could actually analyze.
Yeah.
Which I think
Pictures,
is
right?
the other piece of this is we just need camera traps like everywhere. And then people can spend time, it can be gamified. There's all sorts of cool stuff that can be done where you can really quickly, an AI can kind of teach you how to identify things. And then you can be doing a lot of the hard work of sifting through these camera traps, 5 minutes here, 10 minutes there. And you can actually be teaching an AI to be better at it itself while you're doing that. So that's one of those things that you don't have to be a PhD in conservation bio to be able to analyze camera trap footage. So that's, I think it's definitely, it's a resource that could and should be tapped more for that reason.
Totally. I love it. Shoe Brew in the chat room says camera traps, shoot pictures, not bullets.
Yes, exactly.
I like, absolutely. Great motto. I love it. But yeah, let's track the wildlife. Let's see who actually lives where and see how many animals and how much wildlife we can preserve. Speaking of preserving, wine in my household usually is not preserved very long, but Justin, tell me about your wine story. What's going on there?
So wine drinkers are often portrayed as, or actually participate in, trying to find the perfectly paired wine that can make a delicious meal taste even better than it would have without the wine. Right. It has to be the right wine. But it actually might be the other way around it might be the food that's being chosen actually is making the wine taste better. This might be the bigger effect. So this is researchers reporting in the Journal of Agriculture and Food Chemistry have explored how lipids, fatty molecules that you might find in a cheese or meat dish, your olive oil, other types of foods, vegetable oils, how they interact with the tannins of grape. And they found it's actually can mask and maybe even change some of the undesirable flavors that might be in the wine compound. So the tannins are responsible for the bitterness, the astringency of red wines. And they had noticed over the years, people who do test wines, that certain food combinations reduce the sensations. So what the researchers did, they made this pretty simple sounding oil and water emulsion using olive oil and an emulsifier. They added some grape tannin. They studied the lipids in the emulsion with various biophysical techniques. What it really came down to was the taste tests. Volunteers indicated olive oil had the effect of causing tannins that were without the olive oil perceived as astringent. They had a fruity taste instead. So yeah, combining the biophysical and the sensory results, researchers concluded that the tannins can interact with oil droplets in the mouth, along with the food, making them less available to bind to saliva proteins and cause the astringent. So yeah, if you want to really experience a wine to its fullest, but don't necessarily want to have a big meal, a little spoonful of olive oil, how to do it. You might get a different flavor from your wine.
As opposed to a spoonful of sugar, a spoonful of olive oil.
Ooh, sugar, spoonful of sugar in your wine sounds real gross. That's called juice. No, I was thinking specifically when you were talking about the olive oil, I was thinking about when really fancy Italian restaurants will have like the focaccia or some sort of herb bread that you dip in the olive oil. It just tastes so good.
Yeah, let's just have a little bit of olive oil and maybe balsamic vinegar, like mix sort of sitting on the table. You just dip it in while you're waiting for your food to get ready.
I want to go to a restaurant. Oh no.
But so is this oil, is this part of the reason why cheese and wine go so well together? Because of the oil masking the astringency.
It would be the lipids in there that can mask some of the astringency. So it's the idea. Maybe you think, maybe it has an effect the other way around too. I guess that could still be possible. But they definitely have sourced a way in which the food alters the flavor of the wine itself.
Cool. These things, they work together, not on their own. Two great tastes. Food and wine. Good. Blair.
Yes.
Moving on from wine. Yes.
Yeah,
where are you taking us?
When they don't want to be food, a lot of them will play dead. Think about opossums, but there's lots of actually invertebrates that do it as well. So this was a study published in the Science Journal Biology Letters that evaluated the benefits of death feigning in terms of predators visiting small populations of conspicuous prey.
How beneficial is it to play dead?
Yes, and how long and when is it beneficial and when is it not beneficial? Right. They used computer simulations that utilized marginal value theorem, which the lead author of the paper, Professor Nigel R. Franks from University of Bristol School of Biological Sciences, explains it. Quote, imagine you are in a garden full of identical soft fruit bushes. You go to the first bush. Initially, collecting and consuming fruit is fast and easy, but as you strip the bush, finding more fruit gets harder and harder and more time consuming. So at some stage, you decide to leave to go to another bush. You are greedy and you want to eat as many fruit as quickly as possible. The marginal value theorem tells you how long to spend at each bush, given that time is lost moving from one bush to another. Right. So what they found was that with beetles that can remain stationary for 23 minutes, antlions, some of them 61 minutes, they have this very long amount of time that they'll pretend to be dead, but it's not consistent. There's no predictability in how long they will pretend to be dead. So the idea is that they become a waste of time. By playing dead and there being no predictability on how long you're going to play dead, it behooves the predator to give up and leave. because they have no idea how long it's going to take. If you think about a line at Disneyland, which I'm going to just kind of put salt in the wound again and talk about Disneyland now after restaurants. But if you think about the line at Disneyland, if it says the line for Space Mountain is 30 minutes, you're like, oh, that's fine, no problem. If the line says it's 120 minutes, you might be like, no way. Or you might be like, I'm going to go get some food and eat it in line for 2 hours. I don't know. But if it says question mark, question mark, question mark, you can't see where it starts and you can't see where it ends. Is it better to get in that line, or is it better to go somewhere where you know how long it's going to take to get on?
Yep.
So that's
predictability is better.
Yeah, exactly. So essentially, they posit that the arms race between predators and prey in relation to death feigning has been prolonged so long through evolutionary time that it can't be bettered. It's gotten as good as it's going to get because it's found this kind of critical mass of being long enough. Because this is the other problem is if you're out of it in foraging or daylight hours or whatever it is that as a prey item you need, right?
Yeah.
If you're out of that for too long, then avoiding being eaten isn't good enough if you're going to starve or you're going to be stuck out at night or any of these things, right? So there's a perfect medium between playing dead and losing time as prey and playing dead and making predators give up on you. And so that's the idea here. It's pretty much, it's gotten as good as it's going to get. And it's also like
playing Possum.
It's highly convergent. This has happened all over the animal kingdom.
So first I was thinking, well, like, I hope there's no scavengers around. But a lot of scavengers are going to look for either something that's been dead for a while. Like your rodents and squirrels will usually wait 16 days before scavenging a carcass. Whereas some animals might want it fresher, but they're probably still looking for that making sure it's dead smell before they go in.
And also keep in mind, if a scavenger goes up to an animal that's still alive and tries to take a bite out of it,
that's
that animal that's alive,
danger.
And then the scavenger goes, "Oh no, you're too much trouble. Goodbye."
Yeah, and I think that's why there's because you don't have to wait that long for there to be the scent of the insides on the outsides kind of a thing taking place. Mm-hmm. It sounds like a pretty good strategy.
Yeah, just waste your opponent's time. I actually really like that idea.
And I love the fact that there's randomness involved, that lack of predictability, that between species, between individuals, there's no knowing how long they are going to play dead. And even individuals between different playing dead sessions, we're going to spend different amounts of time. And so that whole aspect of randomness lends itself to this, to the evolution arms race between the predator and the prey and this whole strategy.
Yeah.
Very cool. Randomness. It's a strategy and it's successful. All right. Thinking of other things that, I don't know. Well, they might get better. I don't know. Space hurricanes. You've never heard of a space hurricane, have you?
I heard of the space lasers, but that wasn't a real start. What is the space hurricane?
They're hurricanes in space.
Hurricane.
That makes sense.
So we didn't really know that there were space hurricanes. I mean, we've seen hurricanes in our atmosphere. So atmospheric hurricanes that are the result of differences in air pressure and temperature. And there's that heat engine that gets involved to drive the energetic momentum of the hurricane within our atmosphere. We also see hurricanes in the plasmasphere, the atmospheres of Jupiter, of the sun even. So there are these hurricane-like spiraling masses of energetic materials, right? That these atoms are bouncing against each other energetically, ending up in something of a spiral pattern. Space hurricanes. We didn't ever know about them happening here on Earth, though, until August 20th, 2014. So this was revealed in our upper atmosphere during a retrospective analysis led by Shandong University in China. And the data suggests the hurricane appeared over the North Pole, extending to a diameter of 1,000 kilometers. 110 kilometers to 860 kilometers in altitude. And it was made up of plasma with multiple spiral arms swirling in an anti-clockwise direction at speeds of up to 2,100 meters per second. The center was still, though, just like atmospheric hurricanes. And so the question was, okay, has this happened before? What were the conditions that possibly made this happen? And the researchers had to get to work. So what they are reporting on really is their query into figuring out what exactly happened. And what they think is that the hurricane gets started as the result of a disconnected magnetic field line reconnecting. And that reconnection transfers solar wind energy into the magnetosphere and the ionosphere. And that is what they found leads to this hurricaning system. There are other factors that are also potentially very important. Low solar wind, potentially, so that there's not a lot of solar wind obstructing or affecting the hurricane, that allows these field lines and the plasma to actually get into this energetic conformation. The researchers, who is one of the main researchers, Mike Lockwood, he's a space environment physicist at the University of Reading in the UK. And he went on to say that plasma and magnetic fields in the atmosphere of planets exist throughout the universe. So the findings suggest that space hurricanes may be a very widespread phenomena. Also, because there's plasma involved and magnetic field lines, an aurora occurred at the same time under the position of this space hurricane in our upper ionosphere, in the atmosphere. And so the researchers think that we might be able to look out for aurorae in odd places to be able to indicate that some of these space hurricanes are happening in the future. Yeah. So they also think this is really important to understand, because they think that these space hurricanes will also influence, because this is space weather, it will influence satellite drag, radio communications at very high frequencies. There might be errors in radar location, satellite navigation, and other communication systems. So this kind of a space weather phenomenon on our planet is very important to understand, but we don't.
But it's sort of a polar phenomenon then too, right? Because they found this at the North Pole. Assuming we could find it at the South Pole maybe as well.
Yeah, so potentially at the South Pole. But one thing that I was thinking is that as our pole is shifting, and we do know that the North Pole is rapidly shifting right now, there are disconnections and reconnections of the magnetic field lines. There are also temporary poles that occur at places that are not the North and South Pole. And those temporary poles could also induce this kind of space weather with their connection and reconnection.
That's the way, but there's also there's some sort of a polar cloud phenomena where you get those high, like almost into space clouds that are like way, 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 way higher than they are anywhere else on the planet. That happens occasionally.
Yeah.
So there's like weird stuff taking place under this pole.
I know the poles. It is, yeah, but it's just I love these discoveries of things that we're like, oh, we know so much stuff, and then it's like something that you're like, what? We'd have space hurricanes. I mean, it's
Close
not a
to
hurricane.
home, too.
Plasma hurricanes in around our planet. Yeah.
I would have gone with Space NATO.
Space NATO.
I would have done that one, but that's fine. You can
Plasma
call it a
NATO. All right. Tell me about this dinosaur that's not a dinosaur.
Yeah, around 260 million years ago, Anteosaurus roamed the Earth. Quadruped carnivore the size of an adult hippo, had big canines, a powerful bite, large, dense bones, a thick tail, and it must have been a scavenger or an ambush predator of some sort because it was too heavy and sluggish to catch anything that was still moving. It was so big and bulky. But looks can be deceiving because, as we said, Anteosaurus was no ordinary dinosaur because it actually wasn't a dinosaur. It was a dinocephalian, which is a mammal-like reptile that predated dinosaurs. This one predated dinosaurs by about 30 million years before it stopped existing. So the fossilized bones of this dinocephalian, well, they're found all over the world. This one, I think, was found in South Africa. They always stand out because of their large size, heavy weight, thick, dense bones. Some scientists, this is quoting Dr. Julian Benoit of Evolutionary Studies Institute, University of Witwatersrand. Some scientists even suggested that Anteosaurus was so heavy it could only have lived in water. By carefully reconstructing the skull of Anteosaurus, digitally using X-ray imaging and 3D reconstructions, a team of researchers investigated the internal structures of the skull. What they were looking for is the definitions on the inside of the skull that would give them some concept of brain regions. And they found specific characteristics of its brain and balance organs were developed in such a way that it was probably everything or anything but slow moving. Now, this is quotey voice again of Benoit. Agile predators such as cheetahs and the infamous velociraptor have always had a very specialized nervous system and fine-tuned sensory organs that enable them to track and hunt down prey effectively. We wanted to find out whether this Anteosaurus possessed similar adaptations. Team found that the organ of balance in its inner ear was relatively larger than that of its closest relatives, and most importantly, of other contemporary predators. That this indicates that the Anteosaurus was capable of moving much faster than its prey and its competitors. They also found that the part of the brain responsible for coordinating movements of the eyes with the head was exceptionally large, which would have been something very important if you're moving really fast and tracking something that's running away from you at the same time. In creating the most complete reconstruction of an Anteosaurus skull to date, we found that overall the nervous system of the Anteosaurus was optimized and specialized for hunting swiftly and striking fast, unlike what was previously believed, says Dr. Ashley Kruger, Natural History Museum in Stockholm, Sweden. Yeah. Prehistoric
So it was potentially,
killing machine.
yeah, potentially way more dangerous and feisty than previously considered.
Yep. Don't
Killing
judge a dead,
machine.
not a real dinosaur. You called it a dinosaur, it wasn't a dinosaur. You thought it was slow moving, it's fast moving. You know, you got to keep looking at these things. You might be wrong. Looks can be deceiving.
Scientists, what do they know anyway? No.
Well, that's the thing. It's okay to be wrong.
Exactly. It's you think you know something, but then you collect more data and you understand something much more.
But you can't skip those steps of the collecting data before you can say that you know anything.
Oh, I don't know. I see people do that all the time on social media.
I see people do that in Congress.
All right, my last opening story for this segment of the show is a bunch of lying birds. I mean,
Have you ever really trusted a bird?
Never.
Never.
They're too cunning.
The cunning birds. Well, lyre birds, part of their name comes from their wonderful vocal mimicry. Lyre, spelled Lyre. They are musical and magnificent in the way that they sing their songs, and the males of the lyrebird species are incredibly, I think of them as decadent. They've got these wonderful tail feathers that they shake for their prospective mates. They create these bowers that, or these mounds that they dance for their mates on.
Aren't they the birds that were famous in the David Attenborough videos where they end up looking like just kind of like a black blob with two white eyes and stuff? And they have those crazy shapes that they make out of their body.
Yeah, theirs are more like they have this tail that they bring over their heads from the back and over their heads with these feathers that come forward and bounce like it looks like I don't know, like musical notes, or the on a violin, that that little design that is carved into a violin for resonance. But I am getting away from myself here in what this story actually is about. Oh, and female lyrebirds, on the other hand, female lyrebirds are drab. And they're brown. They're drab birds, but they get to choose. They go inspect, and they look at the lyrebird, the male, while he's singing and dancing and strutting on his mound, and they go inspect the mound. And during courtship, these female birds will enter the display area of the male, and this is one of the important times for where things may go forward or the female may leave. And the male sings a bunch of songs and does a lot of vocalizations in this process. And then the second time that they have discovered that the lyrebird vocalizes and sings is during copulation. And very often during copulation...
So they're just like us. The more you learn about the animal kingdom, the more you find there's no different than humans.
Lyrebirds. They're just like us. Yes. Well, these male lyrebirds, they kind of get into this practice where it's called the vocal mimicry of a mobbing flock of birds. And sometimes birds will imitate a mobbing flock. And this happens, a mobbing flock is what occurs when there's a predator and one bird puts out an alarm signal, and then everybody starts to make a bunch of noise and mob the predator to scare them away or get rid of them. And during courtship and during displays, very often these kinds of mobbing calls occur because it's a highly protective period of time. Researchers set out to record the mating songs of lyrebirds in southeastern Australia. And while they were out there, they heard the sounds of a mobbing flock. This is the sound of an experimentally induced mixed species mobbing flock. So this is researchers they got a predator. They had a predator bird in a cage or they had like a dead bird that they brought near a flock of birds and got birds to make mobbing sounds. So this is the sound of a mixed species, lots of different species, mobbing. It's a mob. It's just,
yeah, I was pretty close.
These birds are going crazy, right? Okay, and so they're recording and they're out in the field and they hear one of these lyrebirds start making the sounds of a mobbing flock during copulation. And this is the sound of a male lyrebird imitating a mobbing flock.
Part of
There,
me
your
just
face.
realized. Well, we are listening to the sound of birds having sex. I mean, you do realize that's what
we are.
Okay,
It's also just like, yeah, that first one sounded like birds, and this one also sounds like birds.
It sounds birds
You have
sounding
to have
like birds.
You
Exactly.
have to slow it way down.
You
and
have
then
the
you look at
refined palate. I understand.
We just don't hear fast enough. But are they okay? But what are they doing?
Yes,
Are they
so-
telling the other birds there's a predator here? Stay away from this area while they're having sex. Or
Yeah.
are they
So that is the
asking
question.
for help?
And that is the question, and it's hard to know. So these lyre birds, they investigated the call structure of the lyre birds and the call structures of the mobbing flock, and they found that there was a lot of traits in common between the calls. And so this is how, it wasn't just listening to the recording and go, oh, this sounds like a mobbing flock. They actually looked at the structure of the call. During the process of copulation, the male will also take his wings and cover up the female's head so that
nothing
she
to
can't
see here.
Nothing to see here. Meanwhile, mobbing flock, look at me protecting you. It's very curious, and the researchers don't know really what is up with it at all, but this is something that they came across that they did not expect, and the sound is only made during copulation or when females decided to break off early from the interaction, as they say.
Okay, wait a second. So maybe the sound is for the female who has. If the females don't respond to the call to
Display.
arms,
Yeah, look
and
at me.
aren't trying to scare off. If they're not scaring off the predators with that sound, with the mob call, they might assume, because they can't see, that there's a predator nearby, and so they better not move until. Wow, that's one hell of a tactic.
Right? The tactic, maybe I'll just make this noise and convince the female there's a predator nearby and I can keep her safe.
Or immobile.
Anyway, lying lyre birds. Lyre. Lying lyre birds. I love birds. This is just.
I really should go. Baby, there's a hawk out there. I don't see one anywhere. Close your eyes and listen to this sound. It's kind of a rapey bird sound. Not cool.
Not cool. Oh, lying lyre birds, unexpectedly.
Now I really do feel dirty. Yeah, JG in the chat room. I also now feel dirty for having listened to that. Thank you.
I have bad
You're
news
welcome.
for most copulation in the animal kingdom, if that's the case.
Right. This is This Week in Science. Thank you so much for being here with us. We are so glad that you are joining us right now. If you are able, subscribe to the show and maybe get a friend to subscribe as well. All right, we're coming on back with this part of the show that we know so well as Blair's Animal Corner with Blair.
She loves our creature, great and small. Biped, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Oh, I have cuttlefish. What do we know about cuttlefish?
They're not as cuddly as you think they are.
True. What else?
Cuttlefish are very intelligent.
Yes, that's the one.
Yes. Okay, good. I got it.
We have talked so many times on this show about the marshmallow test. We should all be very familiar with it at this point. It's used on usually human toddlers where they can have an immediate reward. Okay, you can eat this one marshmallow right now. Or if you don't eat this marshmallow right now, in a little bit, I'll give you 2 marshmallows. So, of course, there's a lot of children don't pass this test until they get to be
a lot of grown-ups don't either.
A lot of grown-ups don't. We also had a story on the show where, depending on your socioeconomic background, that can have an impact. There's all sorts of cultural and socioeconomic and all sorts of interesting markers that can have an impact on this test. But this is a pretty consistent delayed gratification test used on humans. But a modified version of that with shrimp has been used on cuttlefish, and they appear to do very well. Some of them were able to wait 50 to 130 seconds, which may not sound like a lot, but that is something that they have tested in chimpanzees, crows, parrots, and that's pretty consistent with them.
Right.
So they can even wait longer for a meal. They found that the cuttlefish that waited longest for meals actually did better on cognitive performance tests. So not only did they have this ability for delayed gratification, but it was often linked to other cognitive performance. So the way they did that is after they did this modified marshmallow test, they were trained to associate a visual cue with a food reward, and then they reversed it so the reward became associated with something else, and you had to see kind of how long it took them to adjust their behavior. And the ones that did best were also the ones that did best delayed gratification. Now, the big question here is, why are cuttlefish good at this? Because the understanding is, and so often with conventional understanding, especially when it comes to animal intelligence, it's all, a lot of assumptions. But basically, the assumption was that delayed gratification in humans has to do with social bonds. They're waiting to eat so a partner can eat, or they're waiting for something so that it benefits the species as a whole. So basically, it's based in guilt. You're telling the child, don't eat that marshmallow now, and they have to conform to this expectation that you've put upon them for some reason. That's my Blair-splaining of the sciencey words to this, which is basically just that they think that it is somehow a social cue.
Right.
The other thought is that it could be somehow related to tool building, because waiting to hunt while constructing a tool is related to delayed gratification. I could eat
you have to
something
take the
small
time
now,
right. Or I can get something bigger if I make this tool and go hunt for it.
Exactly.
It's doing the work before you get the reward.
Right.
Yeah.
The problem here is cuttlefish are not social, and as far as we know, they do not build tools.
Darn it.
So why can they do this thing? So now their guess is that it has to do with camouflage. And that's because these cuttlefish have this amazing camouflage where they blend in almost imperceptibly to their surroundings. But they can't eat while that's happening, and they actually break camouflage when they forage. So that exposes them to predation, which means they have to...
Romulan ship.
Yeah.
Can't fire while in cloak.
Mm-hmm. Yeah, exactly. So that means there's a delayed gratification there. They can't eat because if they take that impulse to eat, they'll get eaten. So that's the expectation here, is that it somehow has to do with that. They also say that this means that this is an extreme example of convergent evolution. And this is where the study loses me. Because just because we've only seen this in parrots, crows, chimps, and humans, that does not mean it isn't elsewhere. And I think this is just like our tool use conversation, depending how you categorize delayed gratification, I think you start to see it more places. Do ants in a line bypass that teeny tiny speck of sugar because they're being told there's better food further out? Things like this. Mm-hmm. And that's why I question whether maybe this is convergent evolution, or if this is something that could be really essential to anything that feeds.
Yeah. Yeah.
I don't know. So that's part of the thing, is that, like, I wanted to bring this because it's all over the internet and everyone's talking about cuttlefish passing the marshmallow test. I would explain what that meant, but also because this is another opportunity for us to challenge how animal intelligence is examined.
I think that's the biggest point. That's great. Yeah.
And actually, they could go a step further and study the further implications of the marshmallow test, which is disadvantage the cuttlefish, starve it a little bit, make its meals staccatic and further apart, and see if it can still do it. Because they found in the children's study, when they did this, that it tended to be the affluent kids who could count on snacks in the first place and who had very regular meals in the first place were better able to do the delayed gratification strategy versus those who were came from poor neighborhoods, regardless of race or ethnicity. And they saw this as an opportunity that might not happen again. And so they took the first opportunity.
Yeah. So that's an interesting point when you start bringing in the experience of an animal and what an animal, is it expectation or is it opportunity, and what's actually going on there.
Well, and then the other thing I was thinking about, delayed gratification, that's a lot of basic animal training, especially dogs. Think about training dogs to like not eat stuff that they want to eat
all the time.
How badly do you think that my dog wants to steal my food straight out of my hand while I'm eating it?
Mm-hmm.
But she doesn't, because when she does what she's supposed to, she gets treats. It's like, that's delayed gratification.
Yes.
Totally.
But now walk up to a feral animal that doesn't have somebody steadily feeding them, and you might get a very different result.
Yeah, she also, around dinner time, gets more and more kind of toes over the line with what she's supposed to be doing. Anyway, moving on. I have another story about climate change, specifically global warming, rising global temperatures, and what that could mean for food webs. So we like to talk a lot about this particular ecosystem or this particular species or this particular ocean or this particular forest, or we like to talk about, even when we're trying to use systems thinking, when we talk about climate change, we often talk about specific zoomed in pieces. Even when we're trying to zoom out, we're still talking about forests or oceans. But this is a really, really interesting study by University of Exeter and Queen Mary University of London, looking at food webs, period. How do animals that eat each other, how is that energy transfer impacted by climate change? And this blew me away. Simultaneously made a lot of sense, but it's something that I hadn't really thought about. So they measured the transfer of energy from single-celled algae, phytoplankton, to small animals that eat them, zooplankton. Normally, between prey to predator, as you move up this food chain, they're called trophic levels, there is a 10% carryover of energy, which is one of the reasons that there's part of the movement to eat less meat is to make food availability better, because on the same land, the same area of land, you can get 10 times as many calories out of corn as you can out of cows that eat grass on that land. So there's this factor of 10 between trophic levels. What they found in this study was that in about a 4 degrees Celsius warming event, so that when that occurs, the energy transfer up the food web was reduced by up to 56%. So now you're turning 10%
56?
into
What?
5%. Yes.
Yeah.
So the reason that this 10% factor is involved is because organisms spend energy to exist. So when I eat food, a lot of that goes to maintain homeostasis, to maintain my body temperature, to beat my heart, to contract muscles, all this kind of stuff that is not building muscle and fat. So only a very small fraction of the energy I consume is retained in my actual biomass. That's what that factor of 10 is. But when you increase the temperature, metabolic rates accelerate, and that reduces energy available to predators as you move up the food web. This was tested in a 7-year-long outdoor warming experiment in the UK. And this shows, again, this is just phytoplankton to zooplankton, but this shows evidence that there is a fundamental cost across trophic levels related to climate change, which of course has an impact on the food that we eat.
Major impact.
Obviously.
Yeah.
But this is impact on everything. Everything eats something. So the only thing that wouldn't really be impacted here potentially is plants, but we don't know if this is also being impacted from the nutrients that they use to grow. That could also be part of this process. That could be messing up their metabolic processes. So there's lots of follow-up that could be done here, but ultimately the fundamental metabolic processes of life could be impacted just by warming.
Great.
So I guess if I could if I could try to make this not sound so terrible.
Yeah.
This whole time we've been talking about systems thinking. Now we need to be talking about systems thinking in terms of the whole planet, which we should have been doing this whole time, of course. But this isn't, it's hurting the rainforest and it's hurting the oceans. It is hurting the fundamental processes of life all over the planet. So if you think this doesn't affect you, it affects everyone. Everyone. From phytoplankton to Jeff Bezos. It affects everyone.
It affects everybody.
So figure out what you can do to be part of your community in making climate action and changing the fundamental way that we function as society to reduce that warming in the future. It's the best I can say.
Hopefully we can find a way to work together to do that.
Yeah.
I mean, that is the big issue of our time. And if I think anybody can figure out the science of getting everyone to cooperate on these big global issues, that's a game changer.
Mm-hmm.
Yeah, if they do it the right way. That's my final story later tonight is going to be the worst idea I have ever heard about how to handle just that.
Okay, worst idea ever. Coming up in just a few. In the meantime, this is This Week in Science. Yes, we've just ended Blair's Animal Corner on this World Wildlife Day episode of This Week in Science. Thank you for being a part of the show. And if you want to see more TWIS science like this, week in, week out, maybe even interweek, I don't know, more science, support us on Patreon. You can head over to twis.org, click on our Patreon link, and support us at any level of your choosing. We also have PayPal if you would like to support us on PayPal instead of Patreon. But we've got a great community going. It's easy. It's an easy way to fit to your budget and be able to support the ongoing discussion of science in as sane and also, as fun a way as we at TWIS try to do. So thank you for your support. And we really cannot do this without you. All right, coming on back. Justin, what stories did you bring?
Well, I got one that's just for Blair. This is from the American Chemical Society. Nano. Researchers report infusing contact lenses with gold nanoparticles to create a safer way to see colors. Because, some of the things that can happen if you're colorblind, I assume, is not being able to tell whether or not a banana is ripe until you've opened it, maybe. Your socks are probably always different colors. The workflow diagram at work or the test at school, if it's color-coded with green and red, you're doomed. And so Blair, I was going to ask her some questions about this, but we got her the chromatic glasses that allowed her to see color. Those distinctions between them.
Yeah.
It worked.
Yep.
Problem is, they don't make them prescription. I don't even know if you can get them prescription, those sorts of glasses. So this is Ahmed, Saleh and Haider Butt of the Department of Mechanical Engineering, Khalifa University, Abu Dhabi. Them and some colleagues took up the challenge to create some prescription contact lenses that could also operate as fixing color blindness. They mixed gold nanoparticles into a hydrogel polymer. They produced some rose-tinted gels that filtered light to... Already, I want to know if that gives you rose-colored eyes. That would be kind of freaky cool. But
it would be.
But it filtered light between 520 and 580 nanometers. These are the wavelengths where red and green kind of overlap. And apparently, this is a big part of the confusion for people with color blindness. Is their vision gets tuned there and can't really distinguish what color it is because the colors are overlapping in that region. So the lenses block that section, leaving the rest of it more obvious. Lenses had good water retention properties, similar to those of commercial ones. They used commercial ones, I think, as the material base in the first place. And they were not toxic to growing cells because the only thing it really looks like they've added is these golden nanoparticles, which shouldn't be super bacteria friendly. Anyway, the next step is to conduct some clinical trials with human patients to assess comfort.
Right. So do the gold nanoparticles affect the way that they feel when they're being worn? Do they change how long you can wear them? Does it make it a rougher surface? Does it make them stiffer?
Yeah, it's not.
Those are all questions.
That was a crazy thing too. I hadn't really thought about too much because I'm not Blair. But
yeah.
But oh, hey, your vision's fixed. Why don't you wear them all the time? And I guess the answer probably is I still need vision. Right? I need to be able to read on top of tell what a color is. So.
Right. And if you're reading, if you're reading black and white text, not having to yeah. But I it's interesting, the idea of adding in this kind of chromatic correction potentially in addition to prescription. Like you could have your prescription lens with this coating to be able to allow you so you can see outdoors all the colors all the time.
And I don't actually know. I couldn't tell from this if they were making a claim or anything about the chromatic glasses, whether they just don't make them as prescription currently, or if it's somehow that material cannot be utilized correctionally. Like the lensing it in such a way messes up the effect.
I don't think so. I think it's just a colored lens. Yeah. I don't think doing prescription would affect it.
Work.
Yeah.
But maybe I can sort of imagine if it's bulking up or thinning out in certain portions of it that maybe it does affect. I don't know. Be really interesting to find out. And then my last story is the dumbest idea around climate change that I have ever heard. But it makes perfect sense who it's coming from. Researchers from Princeton University, University College Cork, and HEC Montreal have developed what they think is a systematic ethical framework for addressing climate winners, as well as those harmed, using financial transfers. Their approach, they are calling polluter pays, then receives, requires polluters to first compensate those most harmed by climate change. Subsequently, polluters would then be eligible to receive compensation from those who are passively benefiting from the positives of climate change. They published in Economics and Philosophy. The article emphasizes that. Those are the words. Those are the words.
I'm benefiting, so I'll pay you because you're not benefiting. So is this a new trickle down?
No, the idea, it's retaining wealth in that sector. And it ignores a tremendous amount of reality also in that the polluters, once we get to the point where laws are passed, are going to even exist because we would have this change in the energy sources, and those companies are mining companies essentially at the core. So they're not even... This is published in Economics and Philosophy. two things that can be meaningful and can also be completely vacuous of actual evidence to support them. The article emphasizes that through climate change, greenhouse gas emitters affect a variety of individuals and groups, both positively and negatively, at different regional or sectoral scales, sometimes at the expense of other groups, what economists call externalities. That's us, by the way. You, me, the planet, all humans, all life on Earth.
Compared to our economy, we're an externality.
In the eyes of an economist, we are externalities to the damage of climate change. Anyway, this is a quotey voice of somebody at Princeton. Qian Mintz-Wu, who's a co-author of the study. With a global issue like climate change, it's difficult for people to make decisions that account for the harm or benefit their actions cause, because those effects aren't directly or proportionally felt by that actor. Our research argues that payments are one way to help correct incentives. Harms should be redressed, and then beneficial actions should be rewarded. Mintz-Wu recently joined the Department of Philosophy and Environment Research Institute at University of Cork, College at Cork. While globally, the negative consequences of climate change are expected to far outweigh the benefits, some groups or places may experience net benefits. For example, countries at the far northern latitudes or specific industries may see improved agricultural conditions, which they don't understand agriculture then, because that's not necessarily how that works. Additional tourism, if people aren't starving and having civil wars everywhere at that point, or lower energy costs. So the idea is the energy companies, us presumably fossil fuel companies, could charge those who have lower energy costs for that benefit that they created for them. The authors say, and of course, because they would be not paying for anything outside of a national basis, though it seems like kind of weird because you wouldn't be paying for all the land loss and the flooded cities in other certain countries. It would only be with certain trading partners. It's just ridiculous. Not systematically considering accounting for beneficial climate effects makes it easier for climate impact skeptics to think that climate change discussions are oversimplified or alarmist.
So this is there is that place in there where things are not going to be equally distributed bad all over the planet, right? That's
silver linings.
That's given. True. There are some places that are going to do great, other places that are not. Canada's probably going to do pretty well. Florida, Texas, no, not so well at all. There's going to be differences in different places.
So yeah, you're right. There's positives. There's going to be positives.
There's positives.
I'm not saying there's not positives.
But so I'm getting, okay, this is an economic way that they're trying to balance it all out, basically being like, hey, you didn't, or Canada didn't earn this good environment. It's just a fact of climate change. You know, Texas and Florida didn't earn the bad environment necessarily. And how do you balance all that out? How do we benefit? How can we pass some of the benefits of places in northern latitudes to the detriments in places like Bangladesh, where people are being currently flooded out of their homes?
Almost say that.
Yeah. Almost.
Justin, no relation, Lyre, professor of applied economics at HEC Montreal. Another motivation of our study was to address the unfairness that arises when some benefit from climate change while others are suffering harm, which sounds like what you're saying.
Yeah.
Flooding in Bangladesh, maybe America and China should kick in for that, right?
Right.
It's a question of solidarity. Still sounds like it's on that right path. Both sharing benefits that weren't truly earned and compensating losses. Yeah, you're earning a fine. By the way, you're talking about also entirely revamping the infrastructure for northern latitudes that don't have any air conditioning in any homes whatsoever.
Yeah.
There's a real win. They explore. Okay, so the authors say that this compensation approach could be experimented with at a regional or national level before being introduced globally. So yeah, no, Bangladesh will have been underwater for so long before we get around to just making sure the fossil fuel companies have money on the exit. Explore how it might be implemented. And anyways, yeah, the dumbest idea I think I have heard in a really long time. You're gonna charge? Who are you charging? You're gonna charge Norway for not having run the heater in the winter? Nobody's doing that. Nobody's charging Norway.
And I guess the question is this isn't the science of it, this is the implementation of tax policies, but who will decide on who gets taxed and when they get taxed and how much they get taxed? And who is going to if they're talking about local and regional taxes, I am pretty sure that, the local government in Svalbard, Sweden, is not going to be saying, yeah, we should tax ourselves for the nice weather and, the melted snow that we have up here. No, it's good.
Yeah, so they're saying they could a national carbon tax can be used to collect funds from greenhouse emitters.
True. Yes.
Of course, it's we end up paying those taxes anyway. Taxes is taxes. It's everybody. The cost goes up for the taxes anyway. That's usually what happens. Those revenues would first and foremost be used to compensate victims. Somebody defining what a victim is. Again, you're right. This is not a specific plan. In addition, a corporate tax would be levied on the sectors of the economy that gain passively from climate change, which, in a way, you could imagine that being, well, your solar panels and your wind farms are doing well because we've been transitioning due to climate change to green economy, so you should pay back the fossil fuel industry for having wrecked the planet because you're benefiting from it financially. Yeah, this is just, and we're all externalities. All wildlife is externality. All, fish, bird, bug, plant, death. You know what? Economists someday are going to admit you don't know what you're talking about. Someday they're going to admit. We just watch the numbers go up and down and talk about them after the fact. Yeah. But we don't know why. We really don't know anything. Ridiculous.
No. Yeah.
Anyway.
Yeah. Anyway. Yeah. Yeah. Okay. I will agree with you on that one. There are probably many better solutions out there. I hope one of our listeners has better solutions. I imagine that they do. Head over to TWIS.org if you are interested in one of these cool TWIS sweatshirts. I've got a blue-footed booby on my back. Thanks to Blair.
One of those. Those are really nice. I like it.
Yeah, it's got TWIS logo on the front. It's got pretty art on the back. It's comfortable. I love this sweatshirt. You too can get a blue-footed booby sweatshirt. Head over to TWIS.org, click on our Zazzle link, and get yourself a sweatshirt or some other bit of merchandise. This is This Week in Science. And I have a couple more stories. You ready, Justin?
Yeah.
Yeah, let's talk about Neanderthals. We've talked about them before. Justin talks about them a lot on the show. This story, the question has always been whether or not Neanderthals had speech like humans, could have produced speech like humans. We haven't seen like the hyoid bone. We haven't seen the structures in the Neanderthal skeleton to date that would indicate that their tongue, that their throat, that any of the structures that we have as humans that allow us to create the speech sounds that we use, that would have been possible for Neanderthals. Now, they would have made sounds, of course.
Yeah. And I have said on the show many times that they must have. In fact, even Homo erectus, maybe even Homo habilis must have, because they passed down tool knowledge over millions of years that went almost unchanged. And it's fine enough that you could have watched it and maybe picked up some stuff, but really, you probably had to communicate some core things from time to time to be that stable of a society.
Right. Yes, and these are large groups that were working together. You had this technology passed down, right? So there had to be some way for that knowledge to transfer. And so speech, language of some sort, communication of some sort would have been important. But like I said, we haven't had the evidence to support Neanderthals having the kind of speech that we think that the human lineage has had for a very, 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 very long time. So researchers in Binghamton University in the state of New York, they worked on Spanish Neanderthal skulls. They were looking at the Neanderthal skulls using 3D models based on CT scans of these Spanish Neanderthal skulls. And the researchers were comparing Neanderthals from the age, kind of that age when Neanderthals and modern humans may have been intermixing or around the same period of time, and Neanderthal ancestors, skulls that also had been found earlier, fossils in that region of Spain. The CT scans and the 3D models, they decided to look at not the speech production structures, but the structures of the ear. So here's the Atapuerca fossils that they were looking at in Spain. So the structures of the
hole.
Not necessarily. They have been able to use CT models, 3D models of lots of species to determine the frequencies, the field of auditory detection that an animal might use for hearing. And not just the range of frequencies, but to be able to tune in on the narrow band of frequencies that are most important to an animal. Those frequencies used for interspecific communication with others of your species. So they looked in, and these are software-based models that have been developed for auditory bioengineering. This is modern, very modern technology. So they looked at these old Neanderthal ancestral fossils. They looked at Neanderthals and they looked at modern humans, and they found that they estimate the hearing abilities up to about 5 kilohertz, which is within the range of human speech sounds. Neanderthals showed better hearing than their ancestors, between about 4 to 5 kilohertz, and this resembles modern humans. So from this, the key takeaway is that there was the ability to detect the range of sounds similar to the range of sounds that humans make for speech. They also think that there is evidence for speech capacities in the use of consonants, and that not just vowel sounds being important, and that's what a lot of the old research has been looking at, but that there is the structural capacity for the production of consonants in Neanderthals. And so altogether, they say that the ear of the Neanderthal was tuned to perceive frequencies produced in human speech, which indicates that Neanderthals were probably creating speech sounds within the same range themselves. So Neanderthals may have sounded like humans a little, and maybe they even listened to and understood humans a little.
So, but okay, well, I believe that anyway. I've already believed that. That's fine. However, it's a weird thing when you're talking about hearing range. I mean, what ancestors couldn't hear the range of human speech? How varied was it? And then, what's to say if it was moved slightly outside of part of the range of human speech, that they communicated with different frequencies. They maybe didn't do the high sounds. Like they couldn't hear the punchline to any Jerry Seinfeld joke. Right? But that doesn't mean.
I'm just going to say, to have the 3D models work out that the structures of the ear would be tuned specifically to the primary range of human speech sounds. Not, I mean, it is able to pick up a broader range, but it's primarily tuned to the range of sounds that is within that range of sounds produced by humans. So anyway, it implies that they had the auditory capacity, that they probably had a vocal communication capacity.
What would be the point without it? Yeah, that makes sense.
And so instead of doing a vocal structure first, they're doing, okay, if the ears work for it, they probably did. They probably could communicate. Why else would they have ears that were tuned for that kind of communication?
Yeah.
So
and they likely interacted with humans well enough to form bonds enough to have children. Mm-hmm. So
probably
that had to happen. And there's also there's a case of them adopting human tool use in an overlap area where the Neanderthals were using the human tools. Maybe they just found them and said, I could make this. Maybe they maybe not secretly, just watched them make them. Maybe they had a conversation over, a Mastodon barbecue and was like, oh, that's a great idea. I'll try that. Yeah, have you ever thought of that one? Yeah. It's like 400,000 years. Nobody's thought of this. We'll give it a shot.
Hey, Bob, have you ever seen a wrench like this? No.
Yeah,
no.
Totally. Just they're hanging out in each other's garage. You think it's a cave. They called it a garage, just so you know. They didn't have the rest of the house invented yet. Mankind started with garages, and then we added the rest of the house. But then the part that I don't like to rule out, though, is the idea that those predecessors, if they did have different toned ranges, may have been toned for different vocalizations themselves. So it doesn't rule those out. But I do like the overlap and the similarity, although ultimately it's maybe not much separation between Neanderthal and man. So
ultimately,
current modern human man.
Speaking of Neanderthals and humans having sex, why are fewer young adults having casual sex? That is the title. That is the title of a paper published this week in Sociological Research for a Dynamic World. The researchers looked at data from 2007 through 2017 of the panel study of income dynamics transition into adulthood supplement to quantify some of the reasons why young adults are having less sex. And the key takeaway is that, well, more young adults are, especially young men, are living with their parents and playing more video games. That, combined with young women not drinking as much, is contributing to a decline in casual sex. Science. Apparently, and there's this number, the numbers are very interesting. The percentage of adults ages 20 to 24 who did not have sex in the past year increased from 11.67% from 2000 to 2009 to 15.17% in 2010 to 2014. Changing with a different study in a different time frame, another group looked at the percentage of sexually inactive men, 18 to 24, and they found that it increased from the percentage of sexually inactive men increased from 18.9% in 2000 to 2002 to 30.9% in 2016 to 2018. And sexual inactivity in women decreased increased from 15.1 to 19.1% over the same period. Yeah, there are similar decreases, not just young people who are having less sex. It's happening in all sorts of age groups. Less sex is happening across the board. You say Netflix and chill, but you don't mean that. And it's really just my cell phone. I'm happy. Got my social media. No, I don't know.
With
but
all the dating apps that exist in this,
yeah, but there are a lot of things.
But if you live with your parents, and as somebody's pointing out, millennials are working longer hours to make a barely living wage.
Exactly. Times are different now. There's not as much fun and frivolity. There's a lot. Things are harder.
The minimum wage. What is it? Somebody's pointing this out. The minimum wage. What is it? 30 years ago, was the equivalent of $20 an hour today, which is more than twice the federal minimum wage. So
yeah,
it's tough out there.
It is tough out there. Yeah. So young adults, I mean, on the upside, fewer unwanted pregnancies, fewer sexually transmitted diseases. That's the upside of this. But on the other side of it, it potentially means that young adults are not getting the same amount of emotional, physical development as might be beneficial.
I don't know. Have you looked at adult humans of the past and how they turned out? Might not be bad. I don't really know. It's fine. You gotta wait and see. Call that one.
And my last story, because it's the end of the show, I thought this was very important. It's in the proceedings of the National Academy of Sciences. The title just makes me laugh because it's kind of funny. Do conversations end when people want them to?
No.
No, they don't. Across the board.
They go at least a little further than was comfortable.
Yeah,
sometimes much further.
But it's not just one or the other. The researchers found in their studies of 932 conversations, they found that conversants had little idea when their partners wanted the conversation to end and underestimated how discrepant their partner's desires were from their own. They also discovered that it's not just that they never ended when both conversants wanted them to, and rarely when even one conversant wanted them to, but it was that sometimes they went too long, sometimes they were too short also. Sometimes it was the other direction. So not always is it conversations overstaying their welcome and people just not picking up on signs and continuing to talk. And it goes the other way as well, with people shutting conversations down very early. But it gets at this very interesting. We think that we are so good at communicating with other humans. We have small talk, we have networking, we have deep conversations, we have podcasts. And how much do we really know? The crux of this that I think is very interesting is that in a conversation, people are inherently hiding information that would help the other person understand what their views are on how they want the conversation to end. If you're having a conversation, you are putting your interest out there. You're talking, you're continuing to ask questions, even though in your mind you're saying, I'm so done with this. Please end the conversation. But you don't want to be the rude person necessarily. Right? Or it's the other.
Wait, you don't? Oh, that's what I'm doing wrong.
What?
I'm like, I'm done talking. Is that okay?
Is that how you end conversations? You're just like, I'm done.
Like, I was like, you know what? I just reached the limit that I can put into this conversation. I can't talk about this anymore. We can talk another time. I don't mean to be rude. It's just
sometimes I kind of like the way that phone conversations end as opposed to face-to-face conversations, because a phone, have you ever talked on the phone with people who Like all of a sudden, the phone call is over. And they're like, okay, bye. And they just hang up. And you're like,
my 7-year-old does that. My 7-year-old does that. My 7-year-old's like, we're talking, and she's like, okay, I gotta go bye, and hits the button before I say it back. Like, she hasn't figured out or doesn't even wait for you to say it back. She's just, okay, bye, boom, gone.
Yeah.
But I think there's I think there is like a little signal. Well, all right. Or, well, I guess I'll let you go. Meaning, I'm done. There's little, things that people can hint at that you're supposed to pick up on.
Yeah, and you can learn these things, and you can learn to use them yourself. But I love the idea of conversations as you have is this dynamic between the people who are in the conversation. So you have the needs and the wants that are the selfish needs and wants of each individual person, but then also the social requirements that lead to behavioral cues that are not necessarily honest because of the social requirement to not be rude, or the social requirement of, talking to somebody who where does this other person stand in the social hierarchy? What is this relationship to you? How does this conversation affect your relationship? What is this? There are so many factors involved that
I need to start paying closer attention.
I don't know. We talk about dishonest signals in animals all the time. And I find it very interesting to think of humans are buffering our signaling, are giving dishonest signals in conversations. And so as a result, our conversations are either going too short, going too long. We're just not we're not living up to each other's expectations.
Except for right here.
Except for right here.
Except for right here on This Week in Science, where we always wish the conversation didn't have to end.
But now it's the end of the show. So that's where we are, everybody.
We have not really a timeline or time limit to the show, but we do have a point where we've brought you everything that we prepared to talk about this evening.
And that's where we are right now. If you have any questions about COVID or anything else science related, anything about the show, if you just want to write us a little note, send me an email, Kirsten@thisweekinscience.com. You can also you send us a message on Facebook. That works as well. Thank you for joining us. We've made it to the end of this show. This time we're done. It's done. Shout outs to Fada. Thank you so much for all of your help on social media and show notes for YouTube. Your help is invaluable. Identity4, thank you for recording the show and sending me those files every week. Gord, thank you so much for manning the chat room and making sure that everything is working on those fronts. And I would like to thank our Patreon sponsors for all of their support, without which we really could not do what we are doing right now. Thank you to Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Vegard Chefstad, Hal Snyder, Donathan Styles, a.k.a. Don Stylo, John Chioli, Guillaume, John Lee, Ali Coffin, Gaurav Sharma, Shu Brew, Darwin Hannon, Donald Bundes, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Bearden, Noodles Jack, Brian Carrington, Matt Bass, Joshua Fury, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Jim Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Melizon, Johnny Gridley, Kevin Railsback, Flying Out, Christopher Dreyer, Richard Porter, Mark Mazzaros, Artyom, Greg Briggs, John Atwood, two fabulous thespians, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramus, Matt Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Stanton, Paul Disney, Patrick Pecoraro, Gary Steele, Tony S., Ulysses Adkins, Brian Condren, Jason Roberts. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, please head over to TWIS.org and click on the Patreon link. On next week's show, we will be speaking with Jess Phoenix. She's just come out with a book. It's called Misadventure, My Wild Explorations in Science, Lava, and Life. We're going to talk with her about volcano hunting, which I think will be a blast.
We will be back next week, Wednesday, 8 p.m. Pacific time, or Thursday, 5 a.m. Central European time, broadcasting live from our YouTube and Facebook channels and from TWIS.org/live. Want to listen to us as a podcast? Just Google This Week in Science and whatever podcasts are found. And if you enjoyed the show, get your friends to subscribe too. For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org. And you can also sign up for our newsletter.
Yes, you can.
Also, you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover, address, a suggestion for an interview, a haiku that comes to the night, please let us know. We will be back here next week. We hope you will join us again for more great science news. And remember, if you've learned anything from the show,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.